So talk about the future and talk about the cloud, the future of the cloud. So that's going to be the topic of the next panel discussion up here, which is all set up already, more or less. And since we are short of time, I'm calling to Christian again. Christian, are you ready to rumble? And you know Christian already. He's been part of the panel just lately. So hop on in.
Okay, I'm going to moderate from this side this time. We'll switch it up.
All right.
Okay.
Christian, are you using the DeLorean to manifest what you're talking about?
That's right. Where we're going, we don't need roads. We're heading to the future, and AI is our future.
Okay. So here you go. Have fun with Christian.
Thank you so much. I appreciate it. So, yes, we've got an exciting panel here. We have experts who I want to share with you the future that AI is going to bring to us. So, you know what? I'm just going to go ahead and call up our panel. We have Till Stimberg, who is Director of Hybrid IT category for DACH in Russia at Hewlett Packard Enterprise. Till, thank you for joining us today. I've got Mark Carlson, who's the co-chair and technical counsel at SNIA. Thanks, Mark, for joining us. We can clap for the panelists as they come up. George Klauser, who is managing director at Boston Server and Storage Solutions at Boston IT. No. Okay, George is not going to be able to join us today. How about Jeff Witek, Senior Director of Cloud Service Providers at Intel? Alex Sizeland, EMEA Cloud Technologies at Dell. And do we have Isabelle Rabbione here? No? Isabelle, thank you so much for joining us. Fantastic. Boy, we have some heavy hitters here. This is fantastic. I'm excited. Well, you know, we're here to talk about AI, and I want to jump right into it. Knowing your audience is much harder at scale, and as the cloud industry grows, it's essential that the executives who drive it embrace data science, predictive analytics, and machine learning. This is an educational panel where I want you guys to share some expertise with them to give some simple tips to get started with that. What I'd really like to do is start by going down the panel and learning a little bit about each of you and what you guys are doing by starting, I want to ask each of you why AI and why intelligent cloud. In answering, you can tell us a little bit about how you came to this subject. Why don't we start here and we'll just go on right down. Isabelle, could you introduce yourself and talk about why you're focused on AI?
So you said why AI, right?
Yes, why AI?
So first, I introduce myself.
Yes.
I'm working into IBM. And I am managing a technical team in IBM in Europe for supporting our ecosystem of partners, CSPs, on adopting the IBM technology. So we work a lot around cloud and around AI. So back to your question, why AI? We think in IBM that AI is going to be infused into all of the processes. Yes. It's going to be really increasingly ubiquitous into all of our way of living. And especially in IBM, we talk about AI for businesses.
Yes.
So we are convinced, and the research are showing it, that AI is going to be key for all of the businesses. Mm-hmm. It will bring a lot of value, and it will help all of the businesses to stay ahead of the competition, ahead of the market. So
that's great.
AI is very important, and this is why we have AI platform into IBM. And this is what I'm saying to the client.
Fantastic. We are passing mics. There's mics in between each of you. So yes, you guys are sharing mics in between you.
Cool. So hi, I'm Alex Sizeland. I'm a EMEA cloud technologist at Dell Technologies. So like yourself, I work with service providers, cloud service providers. I get involved in a lot of the big transformational cloud projects that we run across EMEA. So we're very much from an AI perspective. If you look at how the industry's evolving, then the predictions are that we're going to see trillions of dollars of revenue flow through AI over the next few years. Right? So And not that far out, right? You know, when you look at kind of mid-2020s, you're starting to see some really big, you know, some really big numbers come up. Those organizations that adopt AI are predicted to be able to jump way ahead of their competitors, right? And as you look over a longer time period, then the gap that creates between those that adopt AI and those that don't adopt AI just gets bigger and bigger and bigger, right? You couple that with what's happening around IoT and around computing at the edge and all of these devices that are creating huge amounts of data, and being able to bring that back to a central core and analyze all of that is starting to deliver real business value for all of our customers, right? So I think you're going to see that area explode over the next few years.
Wonderful.
All right, and I'm Jeff Witek from Intel. So I'm responsible for our cloud service provider platform. So I work with customers to help to utilize our full breadth of technologies, whether it's in the compute space, in storage, and networking, and really design platforms that are meant to address all of their technical and business needs. So my role really spans a wide variety of workloads, but AI is really one of the most important ones right now. So obviously, a lot of AI has been running on Intel Xeon CPUs for a long time, especially in the inference space. Still, most inferencing is still occurring on CPUs. So that's an area where we've really focused a lot right now, is how do we actually optimize the existing base of Intel Xeon CPUs, the next generation processors, to ensure that we're delivering efficiencies in AI workloads as well. Because I think, like others have said, it's becoming a ubiquitous workload. I think the idea that there's some AI workload sitting out there in some data center somewhere, you know, that's a myth. There may be large training clusters that exist in places, but AI is happening everywhere. Inferencing is happening everywhere. Recommendations are being made at the edge. Learning is happening at the edge as well. So it's important that we develop the right technologies across the full spectrum to ensure that people are able to efficiently take advantage of the opportunity.
I'm Mark Carlson. I work for Toshiba Memory, but I'm here representing the Storage Network Industry Association. We're a vendor-neutral organization that brings companies that are up here together and creates standards to increase the market for everybody, right? And great. There's, in our opinion, two kind of aspects of AI when it comes to storage. One is when you have an AI workload that wants the specific storage for that stage of the AI pipeline, right? You have gathering the data, reducing the data, normalizing the data, and then training a model for that data. They all require different kind of access characteristics to the underlying storage. But then there's how can storage actually provide sort of the information, the telemetry out of it, so that you can do a machine learning management of the storage, of your storage infrastructure, of your data center, right? So that information has to come out in a very standardized way if your machine learning model is going to be able to draw any conclusions from it. If every piece of information is different because it's a different manufacturer, different type of storage, it doesn't work. So that's where I'm coming from.
Makes a lot of sense.
Okay. My name is Stimberg. I'm running basically what we call the hybrid IT portfolio for DACH and Russia, so Germany, Austria, Switzerland, and Russia. And I think it was interesting to listen to you. I think there's two aspects of the AI. You know, one, obviously, what we're working with clients is, you know, on how do they use AI for the businesses. So the workloads, I agree, you know, a lot of the workloads that, you know, land on platforms, land on your infrastructure will be kind of AI driven. Yeah. But then I think you touched a good aspect, which I think as HPE we are looking at, and I'm personally looking at a lot, is how do we use, you know, AI, machine learning, all these techniques actually for the infrastructure? Because I think we're spending an awful lot of time, if we're honest, we're still managing infrastructure like we did 10, 20 years ago, right? We maybe don't, you know, we don't have service engineers showing up with floppy drives to get log files. They're sent somewhere. But what we do with the data is, you know, pretty much the same. So I think that's where we're focused on how can we, as you said, sensor data, telemetry data from storage, from compute, networking, how can we use that make everyone's life in the data center, easier.
Well, you've all got me interested, and I think that probably got the interest of the crowd now. So we've established a good why, and I think that we have an incredible amount of representation from some of the people that are doing the coolest work in AI in this industry and for this industry. I'm not going to make each of us go down the panel and go one by one and say, for any more questions but this next one, but since we already hit the why, I also want to ask you a little bit about the what. So I want to see if you guys can give us some examples of how businesses now are using AI to uncover insights and make better decisions. Because I think that gets to the heart of what the people here are interested in as they try to uncover like how they can do the same in their businesses. Maybe we can start with you and go this way.
Yep, and I would actually touch on the second element of my answer before, because I think you're all service providers in this room, right? So, there's the front end, how you can provide kind of, AI platforms, AI as a service. But then it's also about you, how you can use AI in your own business to help you. And I think for service providers, you're competing in a very competitive market, right? Yeah. So kind of, and let's be honest, right? You're competing with the big hyperscalers, in the room. So, but you probably can't afford the same amount of people, and probably PhDs that write all your software code. So I think you need to look at how can you use AI techniques to make your life easier. How can you get away from just maintaining and troubleshooting the environment, right? How can you predict failures, right? We talk a lot about predicting predictive maintenance in the industry, in the manufacturing industry. I think that the same applies to the data center, right? How can you avoid running into an issue, which then probably affects the service and your clients, to kind of predicting and fixing it and having it actually fixed automatically. I think that's, and we see, we have some AI kind of solutions started in the storage space, because that's where we see a lot of problems happening, or at least suspicion that the problem lies in storage. And with some of the technologies applied, really customers can just increase the uptime, much less time spent on really maintaining and managing, because as we also said, I think the market out there is very dynamic. So I guess you all need to focus on kind of competing and developing new services than keeping the lights on.
Yes.
Yeah, there are some sort of future storage architecture changes that will affect the way people deploy these kind of solutions. SSDs, for example, are getting bigger and bigger. I mean, I just saw an announcement for 200 terabyte SSD.
Wow.
And when you have 200 terabytes, even if you have a very high-speed interface, it takes a while to get those 200 terabytes out to some CPU that can search for things.
Sure.
So a trend that seems to be more popular, at least the buzzword, is computational storage, right? Where instead of moving the data up to a CPU complex, send your search app, machine learning recognition, facial recognition, voice recognition app down to where the data is. And don't move the data. Mm-hmm. Move the computation down to where the data is. Yeah. And that will, I think, make some of these bigger SSDs more practical, because you don't have to suck everything out in order to do something with the data. So we've just formed a technical work group to look at computational storage, develop some standard terminology, maybe some standard technologies in that area, so that it doesn't become a rapid proliferation of many different vendors' unique architectures.
All right, I'm going to hit a couple of different areas where we've been engaged with a couple of specific examples. So one thing that we've spent a lot of time on is optimizing the existing deep learning frameworks to ensure that they run as efficiently as possible, especially on Xeon CPUs. And as an example of that, actually, even just from a CPU perspective with inference, we will see about an 11x improvement in inference performance in terms of images per second with ResNet 50 on Café from the time that we launched our Intel Xeon Scalable processor the Skylake one 2 years ago to when we launch the upcoming one here very shortly. So a lot of that is the hardware, but then an even bigger part of it is actually just optimizing the frameworks to make sure they're taking advantage of all the primitives and all of the capabilities within the hardware. And we actually leveraged that recently in one example with AWS. And with AWS, we worked with them on a World Bank project. So there's a World Bank project where they need to compile price parity index for all of the countries in the world. This allows them to index across developing countries, create policies. So it actually ends up having a really big impact on people's lives and the programs that the World Bank and the UN drives in developing nations. And so previously that data had been actually fairly manually collected. So it was actually people going out to markets, to grocery stores, collecting up the pricing data by hand and then submitting it to the World Bank. That takes forever. So they instituted a new program where people actually went out with their smartphones. They just took a picture of items, took a picture of the price tag, and then we worked with AWS to actually create an image classification program that would go in, sort through these millions of crowdsourced photos, extract the pricing, identify the objects. That way you could actually do this in an efficient manner. And then in the end, you end up with much more efficient, much more efficient project and actually more accuracy, which then guides better programs from the UN. So I think we hear a lot of things about classifying cat pictures and things like that. This is an example of image classification that has a really real impact on people's lives. One other thing I'll hit briefly, just on the infrastructure side, the way that it's being used for improvements there. Google, for instance, announced last year that they were starting to actually use AI to improve their cooling algorithms. So previously, if you go back a couple of years, it was really as manual as people looking at the thermometers, going in, adjusting the temperature manually around the data center. Obviously, that involves a ton of waste. Mm-hmm. There was a lot of cooling being applied in places where it really didn't matter, and then probably other areas of the data center that were actually much warmer than they needed to be, which creates inefficiency. So they implemented an AI-based approach to cooling in their data centers, and their PUE went down from somewhere around 1.3 down to less than 1.1. So big improvement in efficiency with that type of an activity. So I think there's some very, very real applications, whether it's preventive maintenance in the data center, whether it's active power and thermal control, more intelligent scheduling. So I think there's a lot of potential in that area to kind of eat our own dog food, I think, in that space.
Yeah, I'm going to build on what on some of the things that Jeff and Till and Mark just said. So if you look at what we're doing just purely from an infrastructure perspective, there's a whole bunch of work going on in terms of integrating AI into infrastructure itself. So we now have our storage platforms with an AI engine built in, so they deal with intelligent placement of workload and looking at what the workload is actually doing and optimizing the performance of the storage to accommodate that kind of activity. And that's just not necessarily for a workload that is AI based. That's more of a storage. That's more of a general purpose workload, but the storage having AI contained within it. We then kind of build on that in terms of, Jeff was talking about frameworks and libraries. So we've done a bunch of work around some of the libraries that Intel have, around Intel Neural, I think is the library, and that's based in so we have a ready solution platform based on that, which is very much about getting customers up and running and out of the gates quickly with AI workloads. So how do you, I think it's estimated that something like 70% of a data scientist's day is taken up with non-data scientist related work, right? So they're doing infrastructure, integration, all of those kind of stuff. So a lot of the activity needs to be around how do we as an IT vendor ecosystem take away some of that pain from them, and that comes back to getting you started quickly, looking at how do we use AI to optimize infrastructure, so taking telemetry data, allowing AI to make decisions on the infrastructure for us. There's a good example. There's a bunch of research going on around how do we look at new workloads that a customer wants to deploy and apply some SLA-based intelligence to that to say, if I turn this workload on this environment, do I destroy the SLA for every other workload on the environment, right? And how do I take that infrastructure and have it automatically adapt to be able to cope with the new things? And that becomes even more relevant when you start looking at multi-cloud. Okay, I now need to figure out how do I deploy that workload seamlessly in 10 different locations, right? So I've got parts of it at the edge, part of it in the data center, probably going to have some on-premise stuff because right now AI needs a serious amount of horsepower. And that's where service providers can really come into play as well. Right? So how do they help? How do service providers provide that service to oversee the whole thing and then also deal with those customers' infrastructure that would normally run in their own data center, but they want to turn that into an OpEx model, right, off-premise, and deal with things like speed of refresh, the pace of infrastructure change. Yeah.
Right. We have, many examples in the different industries of how we are helping our clients, CSPs, to leverage the AI into their businesses. We have many examples around conversational bot or engine. We have a Watson assistant solution, which is one of the best of breed solution in the market from the latest Forrester research. And here we have many examples with the banks and other companies to increase and enhance the client relationship with this type of AI tool, which is very important. It makes a lot of saving on the client side. There are other examples which also I work on regarding energy and utilities, for example, with AI system that allow to make some predictive maintenance. It's always a lot of use case in the industrial sector. And these are, so apart from the well-known use case, when I meet with the CSPs, I mean, the use cases and where we can apply AI is really endless. It is all based on the fact whether data are available and whether there is a real use case. But as soon as we have data, because you were asking, okay, how can we inspire the audience about starting AI projects, infusing AI into the application, right?
Yes.
And I think the starting point is about the data. Making sure we have data available, data which is fair, which is understandable, and which is with no bias. But maybe we will continue the discussion on.
Oh yeah, I'm very interested in talking about all of that. This you've opened up a whole bunch of questions that I want to hit at. And you have such an interesting level of perspective. I mean, I want to talk about storage. I want to talk about multi-cloud and how that. But you're right. We should start with the data. And there, like my first question there comes at. So there's data that you can hand to an AI to process that, like an AI workload, right? I can go to Watson or I can go to something that AWS has the ability to for me to hand it data. And for it to process that data utilizing AI. Some of the other things that I heard about were far more live operations, where we're talking about data that is almost used like, not as a workload, but built into an engineering product, where there's an AI engine built in to analyze the data. When you're dealing with AI, is that two different things? What I guess what I'm saying is, like, there's if we're productizing it for people, right? You've got the AI built in, right, to a product, and then you've got an AI workload where you're handing it data, right? Am I making sense here?
Yeah. I think it's two different things. I think as service providers providing a platform, a service, to where customers can run AI workloads on, right?
Yeah.
Analyze their own data, take value out of the data. And I think the other aspects that we a lot talk, applying and integrating AI into, I think as infrastructure vendors, into our products, into the infrastructure, right? To help, I guess it starts with getting visibility into the infrastructure, better visibility on what's running, where maybe there is, issues, potential issues, optimization possible, going towards, certain levels of automation, trying to avoid issues. And then I think what you mentioned, in the direction of recommendations,
Right.
that's ultimately a little bit what we talk about a lot is kind of the autonomous data center. Ultimately, what is a cloud all about? Customers go to the cloud in any shape or format because they don't want to deal with infrastructure anymore, right? They just want to consume a service. Now, you still deal with the infrastructure in the back, right? Sure. So I guess that second piece is about how do you deal less with the infrastructure, right? How do you, instead of reading best practices documents, if we're honest that once they're out, they're outdated, right?
Right.
How to use, kind of community learning, big data learning to actually give recommendations about, where do you put the workload? That can be, as you said, within, what we're looking at, on what type of storage or what type of kind of compute nodes do you put that next workload? Can you simulate that, right?
Right.
You go in as a user and say, I want to deploy that application, and the system gives you a recommendation, you shouldn't put it here maybe because you're going to kill your SLA for all the rest, right? Traditionally, you've tried it out and kind of then saw the issue. And then in this multi-cloud world, I think growingly look at where do you put this actually? Is it maybe still an on-prem kind of cloud? Is it with a service provider? Is it the public cloud? Right?
Well, I guess that's why I asked the question, because I'm looking at trying to give people advice, and we all understand that when it comes to data, garbage in, garbage out. But when you're talking about actually baking AI solutions into devices, when I'm having it focus its attention on routing tables, I'm not in direct control of the data, right? So that process is being controlled for me. And I wanted to see how you, as people who are developing these technologies, approach things differently when you expect the user to be hands-on versus when you expect them to be hands-off.
So I think you have to bring in this concept of metadata, data about the data, right?
Okay.
Who created it? What is their position in the organization? How many people have they distributed it to? How many people are accessing it? That information needs to be extracted from the infrastructure so that then you can classify this data as to how important is it to keep around, how long should I keep it around, does it fall under X, Y, and Z government regulations, right? And that's the automation that we've been trying to get for the last 10 years, but it's difficult because it doesn't, the instrumentation is not there. The telemetry for the data and how it's used is not coming out of the infrastructure. We got to get that out of the infrastructure. Then we can make intelligent decisions based on that.
And do you have to get it out of the people as well? You talked about data. What data points do you want to, what advice do you want to give to people?
So regarding the data, I mean, what we used to say is that an AI system is as good as the data we put into it, definitely. So this is the starting point, as I said, a use case and the data. So the data, we need to really make sure that they are, first, we have enough data so that we can do something with them. Those data are meaningful, they are bringing a value. And this is, up front when we start a project, and we see that very often when we start a project with a data scientist, we don't really know what we're going to find at the end, at the beginning, right? We are getting the data, we are looking at the data, we put them into our system, into our platform, and they analyze it. And then after we can get some insight. This is how we work on the project. And so it is essential that data are accurate, they are fair, and we can understand those data. This is essential to avoid the bias after that. Otherwise, if we have bias into an AI system, well, because it's all about trust, When will you take the decision to have your solution, which start as a prototype? When will you take the decision to say, okay, I am trusting this solution and I want to have it into production? We have seen recently example, right, where system has been launched and there were some bias into it, and it could be very, generating a lot of, serious damage for the company, for the brand, and for the individual. And so everything is around trust. And trust is really on two things. It is about making sure we have the right data, which are fair, etc., as I said. And then also, trust is about having a tool and the right platform to be able to understand what is the reasoning behind your AI. And this can apply in any industry, right? It could be in IT, because AI is going to make a decision based on data, right? It should not be a black box. It should not be a black box, because otherwise we do not control, and we don't like when we cannot control, right? The business, we don't like it. So we need to have a platform that we can understand what is the reasoning, what were the criteria on which data the system decided to take this decision.
Yeah.
And this is very important. So this is the second point of trust. And also having a platform that can analyze your model and detect potential bias and inform you, alert you. There are potential bias. These are the mitigate. I mean, this is how we could mitigate those bias. So these are the type of platform I think are very important to bring the trust into an AI system. And well, we have some solution around that in AI.
You have some solutions around that. That's fantastic. Yes. Well, this is a diverse ecosystem that focuses on lots of different parts of the development of the internet's infrastructure that are represented in this audience, who's looking for tips on how they can leverage AI themselves. I want to take the lessons you just shared, and I want everybody to stick them in the back of their heads to inform the next few questions that I'm going to ask, which are going to try and take the lens of different parts of the ecosystem's work and try to say, well, how about AI for this group? And you mentioned multi-cloud. So the theme of this event is hyperscale. We are looking at large-scale compute engines. And what I'm hearing more and more, I heard hyperscale, I heard multi-cloud more times this week than I think I've ever heard. And I think that what a lot of people are talking about is going multi-cloud and then figuring out how you use these complex systems and manage them in ways that maybe an individual might not have the ability to constantly do. How can AI help us manage these systems, and can they do it today?
I think it's still early days in terms of using AI to manage a multi-cloud environment right now, but it's definitely coming. Yeah. So when you look at the size and scale of operations that people are going to have to manage as you move over the next few years, then there are limitations to how much you can cost effectively do as a human-based organization. Right? You have to kind of focus on the big decisions around what are you doing as a business initiative, or what are you doing to move into a new business area as a service provider, for example. Less and less the aim is to be less and less on the day-to-day operations stuff, right? So when you look at a multi-cloud environment, that adds layers of complexity, right? So you have your on-premise workloads, maybe in a service provider sitting in an SP data center. We have something like 4,200 clouds out there, right? There are a huge number of clouds that you need to be able to access, manage, and deal with the workloads out there. Right now, one of the things Mark said, is the lack of standardization around telemetry data. So you're dealing with 4,200 clouds. They probably all have a different interface. You probably get a different set of information out of each of them. Yeah. So getting some intelligent information. A couple of people have said about the quality of the data is everything, right? So getting intelligent information out of those and being able to use that through a single pane of glass to actually manipulate where your workloads are placed and automate that over time. So you get a spike in demand. How does the infrastructure adapt to cope with that information, to cope with that? Does it add more scale to the workload where it is? Does it move the workload to a different cloud to make the most of it? Does a hyperscaler suddenly become a more expensive option than doing something on-premise? Certainly will do for a number of workloads, right? So actually, do you start something as a trial in a hyperscale cloud and then move it out? Right? And there's all of those kind of decisions that AI can help and augment. So I think initially we'll move to a phase where AI augments decision making and ultimately humans make the call, right? and then when we reach the point where we have a certain level of trust in the AI, then people will start to let it run on its own. Right?
That builds on what you were saying very well. That's fantastic.
Yeah, there are definitely examples out there already where trusted models are in place, right? So not necessarily for infrastructure orchestration, but you look at companies like MasterCard. We did a bunch of work with those guys. They're doing transaction fraud stuff, right? Those models run autonomously all day, every day, millions of transactions. So we're not that far away, but the data to power individual use cases needs to be created.
I'd like to find out where we are in storage management. Is it a similar answer?
So SNIA has been a long-time storage management standardization organization. We, probably 10 years ago, we created something called SNIA. It's widely adopted, a lot of vendors' products. But it doesn't really scale out very far. It was meant for that old SAN environment in the old days, which is being replaced now with more sort of scale-out storage nodules that are ideally identical as you add more. So recently the SNIA has adopted the Redfish model from DMPF, which is intended to be a scale-out data center style management to not only get the metrics back, but to also represent them as higher level constructs that then decision-making software can actually make sense of, right? Yeah. So if you're getting all the stuff in a standard form out of the infrastructure, now you can do some intelligent things with that data because it's the same for each different vendor, it's the same for each different product, and I expect there'll be a lot of that kind of innovation happen now over the top of both system and storage and network management.
Got it. Okay. Well, okay. Network management. I want to rest on that for a moment. Did you have something else you wanted to say about that?
Well, I just think on the standards piece of it, that's really important. Actually, we've been working with SNIA on some of the Redfish standards. So even I think 2 weeks ago at OCP Summit, we announced that we contributed back the RSD manageability piece of it back in with SNIA. So I think that standardization there is huge. Actually, because when we started to actually look a couple of years ago at how we wanted to do more advanced telemetry monitoring and actually apply AI to it, we actually found one of the biggest problems was that either a lot of telemetry data wasn't even being collected or it wasn't being collected in a standard way, or people didn't even know how to actually collect it back up. So actually the first thing we did a couple of years ago was take a step back, and we created an open source telemetry collector called Snap that's available on GitHub, just to actually help people get to the first step, which was just how do I actually take all this largely unstructured data and actually access it so that I can even start to dump it into a deep learning model and actually start to train. So I think hopefully we're moving down that path right now, and we can actually start to do some more actionable things with it, but there were definitely some hurdles there.
Great.
And I think probably all of us, right, are taking that information from the platforms that Intel provide and surfacing that up through our own management platforms to allow us to propagate that telemetry data out through the wider infrastructure and back to the central points where it needs to be kind of collated, manipulated, and used for decision making. So.
Yeah, I think I would agree. I think we're just at the start. I think currently, I think all of us, different vendors are looking at what do we do around our own infrastructure that we provide. Obviously, we have the most knowledge around it, right? We've started with storage because it's the biggest pain, but I think long term is the question how, because if we're honest, infrastructure is heterogeneous, right? How do we standardize and bring things together so we can apply intelligence to the entire infrastructure, not just islands of it. Right?
So that storage was one of the hardest things to deal with, but you also mentioned network management, and I certainly, I might get similar answers, so maybe I'll switch the focus to maybe forecasting where we might be able to get to when it comes to network management. I'm talking about traffic management across networks, but I'm also talking about threat mitigation. Things like DDoS attacks, malware, and botnets, and being able to identify and quash those things at a live rate using AI. Where do you think we can get to? Anybody?
I would say to stop those attacks immediately before they can damage anything. So this is where we are at the moment with some tool, with some security tool, right?
Well, I mean, that are AI driven. Can you talk about any of that?
Not very specialist in that domain, I have to say. So my personally.
But I would agree. I think probably in the network space, and from our in HPE, the networking space is done by Aruba, and if you look into their portfolio, most of it is actually not around the networking component these days, right? It's around the software and the security piece. So a lot of time spent, and there is a software called Introspect, which is all about how do we identify patterns in the access to the network, how people behave, how the traffic behaves, and take decisions from that, to take clients off the network, for instance, if they misbehave and stuff. So I would actually say in the network security space, we're probably the furthest already if you look at the infrastructure as such from an automation point of view, I would say. Yeah.
Yeah, and then we've started to do a lot of work around that where we're actually looking at the CPU level to actually monitor some of the things that are happening on the network or in other spaces to be able to also take action. So for instance, looking at things like looking at cache accesses, looking at the actual instructions being executed, and looking for patterns that actually appear to be malicious. And we've actually applied some AI algorithms to go and do this as well. There's the obvious stuff where you can figure out what the pattern needs to look like, but then there's the stuff that we can actually detect via AI. So we've got a suite of tools called threat detection technology. It's actually deployed on something like 50 million client PCs today to help try and detect things like cryptojacking, where people are coming in and trying to run crypto mining on people's systems. That happens both on the client side. It's also increasingly happening in the cloud. And then also we've started to employ some of these same techniques to address some of the things around side channel vulnerabilities that have come out over the last year as well. And that's where we've had to use AI because those are very, very complex attacks that people are executing. And so looking at some of the primitive pieces of data that we have in the CPU registers and starting to actually detect when somebody is actually maliciously creating a side channel attack by executing a series of instructions or creating some sort of cache accesses that aren't natural. So we've done a lot of work in that space, and I think there's a lot of potential here to get a lot smarter.
It sounds like a lot of the things, the anecdotes that you're talking about, right back to with that, and going right back to the anecdote you had about Google utilizing AI to manage its cooling. It's all part of trying to maximize cloud uptime, I think. We want to make sure that our systems are online and available at all times. And the people in this room, I think, really appreciate whatever they can do to increase cloud uptime. Are there any other anecdotes before we jump off of that about how we are working to increase cloud uptime writ large that we want to talk about?
I think one of the biggest areas that you can probably make good headway in right now is looking at using AI to looking at AI to understand what is normal behavior for workloads, right? And then start to use that data to predict when you are going to come across a problem. Right? So this is kind of almost intelligent infrastructure or proactive maintenance, proactive alerting around this application is behaving abnormally. We're seeing an unusual situation on the storage, or we're seeing a spike in something happening somewhere in the infrastructure. And what that has the potential to do is stop the snowball effect. Right? So you catch an unusual piece of behavior early before it cascades into something that brings your environment down. Right? So that's definitely one area. That also applies to the security question you were talking about earlier. So what's normal on a network? Right? And understanding when something abnormal happens. Right? A lot of the data to understand that is available from infrastructure today. We're just not collecting it.
So what brings down clouds? People. fat-fingered people. How is AI going to predict that, right? This human is behaving badly.
Yeah.
So cut him off. I don't know. It's difficult.
It does sound as though you're talking about like predicting surges in traffic, predicting problems before they occur. That sounds very similar to what I understand as being the methodology used by the live, like the credit card data, where you're just sitting there saying, "Oh wow, I didn't expect this person to be in Hong Kong spending $2,000. Let's cut them off." Similar technologies?
I think it is, right? If you look at, I think you had examples about certain workloads and stuff. I think it's also then putting that workload into context, right? We had some examples, for instance, with customers. I think the biggest thing about what we see today is actually the uptime. It's actually less even about the reducing kind of workload to the employees, but bringing up the uptime. Because you can predict failures, you can give recommendations at this point in time. I think we're still, not there where people fully trust the system, but it's giving those recommendations also the context, because take the storage example, really simple example. You can have very high response times, right? And I think a traditional kind of monitoring system will just alert you if there is a high response time, right? But actually putting that into context of what is the workload and the application, a higher response time for backup or batch job might not be a problem. It is for a transactional workload. So also when and how do you alarm people, necessary and unnecessarily? I think that's where we're seeing now kind of technologies coming in and making a difference, right?
Yeah, I mean, I think that's the important thing with AI, because a lot of this, if we could do this with rule-based systems for a long, long time, and we either didn't do it because it wasn't effective, because it didn't catch things until they'd already happened, or we didn't do it because it actually creates tons and tons of false alarms, and then we're constantly responding to things that were actually normal behavior. So I think in the context of this discussion, what's important is that AI lets us actually go out and discover the patterns that rules wouldn't have predicted, that we wouldn't have actually come up with, and that allows us to move the response time closer to the time of incident, so now you can at least contain very, very quickly, and also to reduce the number of false positives that occur throughout the process.
That's really interesting, and I just finished reading Cisco's latest cybersecurity report, where they were talking about how much of a problem false alarms is and how much people time that takes. You brought up people. I want to delve into people a little bit. Because the other thing that the people in this room deal with, in addition to trying to mitigate uptime, mitigate downtime and address uptime, is they deal with customer service, where you're dealing with people who maybe made mistakes themselves, who maybe fat-fingered things. And I want to know if AI can help us there too. If AI can, create customer service bots that are truly intelligent, that engage people in ways that actually solve problems.
How do you train a model for error-prone human, right? It can be error-prone in so many different ways. I just don't think it's possible.
You don't think it's possible to be really effective?
So, we have many examples of AI into bot. And I think we should see AI not to replace the human at all, but to enhance, to allow the human to be more efficient, or maybe to do repetitive tasks that can be done by AI, and then the human can concentrate on more high-value tasks, right? And so yes, definitely AI is really very strong into all of the improving the interaction, into call centers, into the conversational type of engine, bringing a lot of value, saving a lot of time and money for the companies, and somehow improving the client satisfaction, because this is what everyone wants to do, right?
Yeah, and I think if you look at incident management and kind of these guys dealing with their clients that probably have done something wrong, and then they call support and say your environment isn't working. I don't think that we're not there where there can be an AI bot kind of answering that. But I think what AI and all the things can do and help is that if their support center picks up the phone, right? They have the insights. The engine has already identified pattern and actually identified what the customer did maybe wrong, and it's a quick fix. We've probably seen, this is what you've done. You should do that, and then we're done. No, we've already done it already. So I think it can change the experience dramatically and speed it up. I don't think you'll see a bot answering the phone, right?
Well, you do. Sorry, go ahead.
Yeah, we also into this domain we also have systems which are, so for example, a call center for IT. We have systems which are already which embed already pre-trained pattern into this specific need for call center for IT department. So they already have some patterns, some use cases in order to accelerate the development of those tools and save money. Yeah.
I will say that go ahead.
I was just going to say I'll give you a slightly different twist on the chatbot side of things. So I agree. I don't think you're going to see AI bots take over kind of level 3, level 4 support anytime soon, right? Those they're very intricate problems that require someone to pick over them in detail, sometimes for weeks, right, to get to an answer. Level 1, first call handling data, actually which team does this need to go to? That potentially is a viable kind of place for that type of technology to start. And if you look at what's happening, so on the Dell Technologies website, if you go to our support site, you have the kind of chat window, right, get chatting to support. Part of the reason that's there is because actually when you do engage in that way, that then creates text data at the back end that we can use in an AI engine to start to improve how we engage with customers and create the data to train the AI over time. So while there's still a human on the end of that doing that, that human doesn't have to then retrospectively go in, type all the information in, all the rest of it. It's all captured and starting to build those capabilities. So I think over time we'll get there, but kind of not yet, right? But it's happening.
And I think you've raised a good point. When we brought in HP, when we brought AI for infrastructure into our kind of portfolio, it came in through an acquisition we did, Nimble Storage, right? And basically the one thing there was, next to the uptime that it creates, was actually Nimble never had a level 1, 2 support organization, because basically all the simple stuff, the simple fixes, right? You enable the customer to do themselves through the kind of AI portal, get recommendation. It might fix really simple things themselves. And then once you get to the level 3, 4, where it really becomes complex, you still need a human being, but it's now assisted by kind of an AI platform that has, worked all the data, find some recommendations. So it also gets quicker then.
I look forward to that future. I think that's going to be great. Right now, my experience is, they do have sort of Siri or Alexa level, like first call responded, like when I call my bank, right? I tend to know how to do things online, and when I end up calling my bank, it generally is because it's something really complex. And so when I get that automated attendant, oh God, what numbers do I have to press to get away from it? So that's something that you need to deal with as you're implementing AI too, is people not wanting to talk to bots. I don't know if we want to get into that now, but it's something that is worth dealing with.
Isabelle raised a point earlier on, which is really, really important. Right? When you're using AI to interact with humans, the question of bias in what you do becomes massively important. Yeah. Right? It's so easy for an AI that's poorly trained to say something or do something inappropriate. There's plenty of examples out there. I mean, if you look, and real world, example of how seriously companies are taking this, right? So just this morning, Google announced that they are partnering with Oxford University to head up a panel specifically focused around ethics in AI and how they approach it. How do they deal with the use of that technology? It's a huge area. So.
In relation to what you just said, and in the example of a bot, you gave the example. it's not because we are, too many times we see projects where we tend to create a conversational tool or bot, and we do the same as if it was a person. We just transfer that with IT, with an AI solution. And this is not the right way to do. Exactly, it's not the right way. It should not just replace. It is not a human, it is an AI system. And the use case or the way we're going to use it should not be exactly the same. It's the wrong way. We should think about it differently on the user interface. What is your need when you're going to call it? Exactly. Where are you? What is your exact need? Not just to start from zero. Otherwise, you get frustrated.
Thank you. I appreciate that answer. Thank you for keeping us out of the uncanny valley. So you guys, you talked about ethics in AI. Let's go ahead and focus the last 5 minutes of our talk on trying to deal with that, because that's a huge issue. How do we ensure that we are building AI for good? This is something that might be worth. Does everybody have an opinion on this? Who would like to address this? Right? It's a big one.
It's a tough one. I think a lot of the use cases for AI right now are not directly human-facing, in as much as we talked about bots, and we talked about, actually you engage with a bot and they give you a direct response direct from an AI. Actually, a lot of the use cases are being used to provide deeper insight into situations that already exist, right? So what they're doing is giving data to humans, and humans are interpreting that data. And in the context of, we've talked a bit about intelligent infrastructure and using AI to understand what's going on in your environment. It's just reporting a fact-based outcome. It's not, you're not inferencing any kind of bias into that model, right? Mm-hmm. Whereas I think it becomes a much trickier subject when you start dealing with AI that starts to interact directly with people, or is making decisions around things that have a very ethical bias to them. So AI in healthcare, for example, can be much more problematic, right? There are big ethical questions around AI in autonomous cars, right? It's a well-known kind of situation. Your autonomous car is driving down the road. Does it run over the baby, or does it kill the driver? Right? It's which one. How do you train an AI to make that decision?
But I think in some of those cases, those are ethical questions that exist already today. They're just being made by individuals on a one-off basis. So to some extent, it actually could provide an opportunity to actually have the ethical conversation up front and actually come to a conclusion by society as to how we actually want to enforce these types of ethics rules, or do we want to actually have consistency across the board? Because it does provide an opportunity for consistency. It just forces the conversation, because again, now it's being brought out into the open versus something that's that's happening privately on a one-off basis, where you're never actually aware of what people's motivations were, or what went into the decision making before they chose to, hit the pedestrian or run into a pole or something.
I think one of the core questions is, if an AI does misbehave, who do you throw in jail? Elon Musk?
That's a good question.
Right? Because it's his car and had the AI in it. Yeah. The designer of the AI that went into the car.
Who's held responsible?
Right. Who is held responsible? And unless there's a definitive meaning for that, you're not getting any change in behavior.
But that's actually moving a little bit away from the ethical piece, because I think in the infrastructure it's less of a question, but your question is a good one also. And we talk about intelligent infrastructure, autonomous data center, and AI in the infrastructure taking a decision, and there's something wrong, to be honest. Who's responsible then? That's another question we'll need to sort out.
We'll need to do a whole other panel just on AI in the SLA. I think that'd be really good.
Yeah, and what I wanted just to add to what you just said is that, indeed, who is responsible for it? And so this is why I think it's very important. I'm back to the trust. Very important that we have AI systems that we can trust. And what does that mean? That means AI systems that we can understand the reasoning. We keep the we keep the control. We can understand the reasoning, understand why this decision has been taken automatically by the system, by the AI system. We need to keep that control. That is essential.
That seems like the best note to leave us on. And honestly, that gives me great more hope for the future of AI than most of the AI conversations that I've heard. So I'm excited to have you here as leaders in this field driving that conversation as long as you stay on that path. Thank you so much for your time here. Let's give our distinguished panel a round of applause.